3, 2, 1. Okay, and we're live. Hello, everyone. Here's Martin from Wire Foundation. Tonight, we have a great pleasure to host two speakers. Jakub Nowosad on top. I hope that's the same display for you. And Robin Lovelace on bottom. This is a very rare collaboration of two people very keen on geospatial analysis. Jakub works as an assistant professor at Adam Mickiewicz University in Poznań. Robin is an assistant professor at University of Leeds. And we will have a pleasure to hear about the recent changes in geospatial world and how to get prepared for them. First part will be held by Jakub. The second part will be held by Robin. And I was asked to say a rumor that is already increased to the size of an urban legend. So this is the rare situation where two people that met the very same day agreed to write a book. And this book was made and published. So thanks to their effort, we have a chance to read Geocomputations with R that is published online. And you can see the URL to slides. And guys, for sure, we'll talk a bit more during the presentation. So that's all from me. Normally, guys, you would have a warm applause, but I'm the only one. So good luck and let's get this started.
Great, nice.
Yeah. Thanks, Martin. Thanks for having us. So let me share our slides. All right, so today we are going to tell you a little bit about recent changes in our spatial. That's my part, and next Robin will move to the how to be ready for them part. So that's our idea for today's talk. I will tell a little bit about our spatial infrastructure and changes in that infrastructure. And I will finish my part with also mentioning some other recent new addition to our spatial world. Mm-hmm. And after me, the second part will be about how to set up your computer properly for our spatial and run Docker. And also there will be some live demo by Robin. So that's, I think, exciting. All right, so maybe let's start with a little bit of introduction. We work with Robin in totally different worlds. I mostly work with environmental data and environmental problems, while Robin mostly work in transportation problems area. But you can see that R can be applied in many different fields, and we have the common terminology, and we have common goal often with Robin. So that's why R is not only good to integrate the different languages or different functions, but also people from different backgrounds on different fields. And what is also important with our spatial is that spatial part can be important in any part of data analysis. So we could have spatial part as the first element of the analysis, so getting some data or preparing some data. Or as you can see on the slides, you can have data visualization in forms or in a form of maps. But next, you can use spatial data for modeling or communicating your results. And what's crucial is that spatial part sometimes is essential and the most important, but sometimes it is not, and that's okay. That's fine. And with R, we can integrate those different aspects and different workflow in this one wonderful tool. So just to finish the introduction, and for some of you, maybe that's the most important slide. There are a lot of resources right now, way more than there were a few years ago, about how to get started and how to get better with spatial skills in R. So here you have three links. The first one is to our website, GeoCompR GitHub.io. This website contains some blog posts, even one published today, some vignettes, some tutorials, but you can also find there a link to our online book, Geocomputation with R. I also put there here are two other links to rspatial.org and r-spatial.org. I know that some people are often confused about those two websites. Those two websites are different websites with different content, and both of them are worth visiting, and because there are a lot of blog posts or tutorials or other materials when you can learn about spatial data analysis. Twitter is also a viable resource for rspatial, and you can find there a lot of people who are interested in this way of working. So we can have hashtag rspatial or hashtag geocomp R. Okay, so in rspatial world, you know that we've got a lot of people from different backgrounds with different expectations, with different goals. So I will show you some examples. So there is a package I have been working on called Landscape Metrics, and this package works on raster data. Some small example you can see in the left bottom corner. So here you've got some landscape, some area, and we want to numerically describe this area. So for example, we want to know if we have aggregated or disaggregated area, or do we have some corridors, or what's the level of connectivity here. And this package allows us to calculate this very specific values and variables. On the other hand, Robin have been working for many years on ST-Planar package, and this package is made to work with routes and network data, where you can calculate connections between points and other calculations like this. So on the one hand, Landscape Metrics is not a standalone package. It has some dependencies, and most important dependencies probably are dependencies related to representation of spatial data. So Landscape Metrics does not contain anything about how to represent spatial data in R. That's a role for different packages. And in R, we mostly represent spatial data and raster spatial data using packages like raster or terra or stars. And you can see some examples of raster data here on the slide. On the other hand, Robin's package, ST-Planar, uses a different representation of spatial data called vector representation. So we can have points and lines and polygons. But again, like in the previous example, this package is not about how to represent this vector data. This is a role for a different package or packages like SP or SF. So we've got Landscape Metrics or ST-Planar. Those packages depends on raster or SF packages, but that's not the end of the story. So SF package also is not alone, and we cannot use all of its functionalities without having some dependencies and having some relationship with other R packages, or as you can see on the bottom of the slide, some external libraries. So on the bottom of the slide, you can see 5 external libraries that are written in C or C++. And I'm going to underline 3 of them, which are probably the most important here. So we've got a PROJ library, we have a GDAL library, and GEOS library. So going from the bottom, GEOS library is used for mostly for like topologic relationships, so looking if our data is touching or intersecting, or what's the relationship with our spatial object. GDAL, on the other hand, its role is to read and write spatial data, because in spatial world we've got hundreds of file formats, and that can be a problem, and was a problem before GDAL was created. But right now we can read hundreds of and write hundreds of spatial data formats using GDAL, and with SF or raster packages we can also read and write them back in R. And the first library that I mentioned on the slide, the library called PROJ, is to convert, its role is to convert coordinates. And I'm going to focus on this library for some time today. But let's have some step back, and this slide represents my old views about software. So my old views was that we are using some software. This software, when it's developed for some years, it became more and more stable, and maybe there's some functionality added to the software and some tiny bugs fixed, but everything works smoothly and without any problems. But right now, my thinking is more like represented by this slide. So right now, my view and reality is that everything moves. So every package and library moves and changes, and those changes have impact on other libraries' changes, and so on and so on. And we need to maintain those changes. We need to be aware of those changes. We need to adjust to those changes. Of course, sometimes those changes are not pleasant, but often those changes can make our life easier and better. So also, when we think about development of open source software, we want to think about it as an orderly process when everything is planned and we are going step by step to some goal, but that's not true. We've got a lot of different people working on different parts of the environment and working with different parts and different software. Therefore, the speed of changes, the pace of changes is huge, which also makes those changes, which are sometimes very impactful or on other developers and users. And when you think about the software, when you are an author of some very specific package like stplanar, when you make some changes in your package, it maybe impacts some of your users. However, if you make a change in package like SF, it could impact other packages that depends on SF, and therefore it can also impact all of the users, all of those packages. And going even deeper, changes in PROJ could have impact on many other libraries and software, including SF, which can have impact on other R packages and many users. Sometimes it takes months to effort to support upstream development and to make those changes that make lives of users easier. And think about it, like when we have those packages, there are a lot of them, as you can see on the slide on the right. There are so many of them that it's really hard to see all of those. So those packages are interconnected, and changes in one of them could have impact in some of the rest. And one of the most important recent changes is change with the PROJ library. So this library, it has a very long history, but in the mid-1990s, there was a very major release with PROJ version 4. And from that moment on until 2010, we were just expecting and seeing some small changes, some fixes and additions to this library. And you can see some examples on the slide here. So on the left top, we've got world in WGS projection, and below we have some projected coordinate reference system. And on the right side, you also have the map on the left is in degrees, and the map on the right is in meters. So that was the time until 2018. And we were living in the world that spatial data was mostly described, and spatial coordinates, their properties were described using something which is called PROJ for string. And you can see two examples of PROJ for string at the top of the slide. So PROJ for string is it's a bunch of characters that describe this projection. So, for example, on the left example, you can see that it's plus PROJ equals to long lat, which means basically that it's longitude and latitude. So this projection will be in degrees. But the right example, you can see that there is PROJ equal to UTM, zone equals to 12. So it's a 12 zone in the UTM projection. And what is also important, we have units equals M, which means that this projection is in meters, not in degrees. And when we know those PROJ for string, we can transform from one projection to another. So we can have the map on the left and the map on the right, and transform them. So that is one way to describe projections. So PROJ for string, and this PROJ for string, one of its properties is that it has infinite amount of different possibilities, and you can create your own projections, and you can manipulate them and change them. There is also a different way to represent projections, or as I should call them, coordinate reference systems, CRS. It is EPSG. So this is a set of codes, so numbers, and those numbers, each number describe a projection. And with this codes, we have some finite amount of different projections possible. And for example, the first PROJ for string can be represented by numbers 4, 3, 2, 6, while the second PROJ for string can be represented by 2, 9, 5, 6. And that was the way how we worked with projections in R until this year. But there were some issues with PROJ 4. As I said already, PROJ 4 was released in mid-90s, and one of the features of PROJ 4 was that it worked with static reference frames, which means that we are simplifying things, and we are stating that world doesn't move, which is of course not true. With all of the plate tectonics and so on, everything is moving all the time. So for example, in Australia, some part of Australia moves 80 millimeters per year. So it's maybe not that much for a year, but it's almost 1 meter per year, per 10 years, sorry. And when you have a projection from 1980s, it's like 3 meters or so difference from that year. And think about it, when your garden should be moved 3 meters away or something like that, or you need to move your fence 3 meters because of the change in projection. Also, with PROJ 4, transformations were made through WGS, so that's world projection. And because of this, we've got some accuracy issues, and that because of that we also got some limited accuracy, and because of that, in 2018, it was decided that we need to make changes, and those changes are going to be large and are going to impact a lot of users. So for more than 20 years, we've got PROJ 4, but right now we moved in 2018 to PROJ 5, in 2019 to PROJ 6, and this year to PROJ 7. And with those new version of this library, especially PROJ 6 and PROJ 7, there are a few important changes. Some of them are not that impactful on our users yet, like ability to use something which is called transformation pipelines, or use of those time-dependent transformations. But some of them are crucial for our spatial users. Like right now, we can make some direct transformations from some CRSs, from some projections to other projections. Also, right now, there is PROJ 4 string is discouraged. Use of PROJ 4 string is discouraged, and also abilities to use PROJ 4 strings are limited right now. So some things that were possible to do even 2 or 3 years ago, right now with newer versions of PROJ are not possible anymore. And probably very, very visible change for our spatial users is that right now we are moving into something which is called OGC WKT2. So it's a new representation of projection in R, which is based on well-known text. And this is a standard ISO that was made by Open Geospatial Consortium. So those changes were known that they are going to happen for some time, and especially crucial work was made here by Roger Bivan, but also by Edgar Pebesma and many other developers in the last several months to move their packages and move their data sets and so on to this new world. This new world when we are working using PROJ 6 or PROJ 7, and we are not longer based on PROJ 4 strings, but we are slowly moving to that WKT to representation of projections. But of course, it has some impact on the users and developers, and it takes a lot of time to adjust. But there are some also, of course, many good things about it. So here you see an example of transformed data. So somebody had a data with WGS projection and want to transform that to a different projection. And before PROJ 6, you can see on the figure above, we've got some artifacts. So we've got some errors with transformations, and because of problems with accuracy that were in that library. Right now with PROJ 6 and PROJ 7, you can see the bottom image. We are not longer having this problem, and that makes life easier and better probably. So just to make it clean and clear how it looks right now. So previously, so for example, before SF version 0.9, spatial projections or coordinate reference systems were represented by a list with 2 components. So one component was EPSG, so there's numbers, this code, and the second component was PROJ 4 string. And you can see example here on the left. So we have an example of data for New Zealand, with EPSG code of 2193 and some PROJ string. So this is a transverse Mercator projection in meters and so on and so on. However, right now with SF version 0.9 and higher, we move to a different way to represent spatial data and spatial projections. Right now, coordinate system is represented by a list with two components, but those components are input and WKT. And you can see that representation below. But let's maybe zoom to that representation for a second. So on the right part of the slide, you can see this representation. So right now, this is how WKT looks like. This is probably, you already see that it's more complex. And when you start, it's probably a little bit tougher to understand, but it's very specific. And because of that, we know what we are doing, and we can specify many different parameters and then many different properties. And this way of representing projections will allow us to use those time-dependent representations and other important features. So to sum up this change, before, when we want to move from one projection to another, we could use either PROJ for string or EPSG code, or we could use just extraction of projections from different data sets. Right now, we should move to either using EPSG code or extracting projection from different data sets. Also, we can use different codes. So we are not only limited to EPSG codes, there are also different codes like codes made by the Esri company. So you can see here example when we projecting data using Esri 54030. And this also represents different projections. Importantly, PROJ for string and use of PROJ for string is still possible. You can still get PROJ for string in SF object, but you can only use that in a limited way. And for most purposes, when you are not sure about that, it's discouraged. Okay, so those were changes, and probably the most important changes, recent changes that happened in last month, and are going to impact users for the next weeks to come. But those are not the only changes that happened. And while making those slides, I just looked at different R projects, R spatial projects, and select just a few other examples. But I need to say that there is a lot of things going on, and many different people are working on very useful and very nice software. And I'm going to only highlight some examples from the last few weeks. One of the examples that is very important for me, for example, is categorical raster data handling in stars. So right now we can easily not only read categorical data in stars, but this data will know about the categories and will know about colors and categories. So you can see that with 4 lines of code, we can have a map of some land cover categories. On the other hand, we also have a new package called Terra. And Terra is the successor of the raster package. And Terra, I think, is started being developed a few years ago, but right now it's on Suran. And what's even more important, you can go to rspatial.org/Terra, and there is a very extensive documentation with a lot of examples, how to read data, how to process data, how to analyze data using the Terra package. Other changes are, for example, in the class int package. So class in package, the role of this package is to split values into groups for better visualization. And there is a new way to create those groups, those breaks, called head tails implementation. And there is a link on the slide. You can click on the link and you can see the very, very extensive vignette about this new implementation, new break. It's very useful when you have values that are very skewed. Another very good change and major release is related to the TMAP package. So TMAP package moved to version 3.0 with a lot of changes. Right now, its engine uses the stars package for raster data, and the TMAP package also allows new ways to plot your data, color your data, and there are still a lot of changes going in TMAP, but I really recommend you to check this package and try it by yourself. Other change and nice development right now, interactive, it's with the map view package. So the map view package is very good for interactive work with spatial data, when you can, in one line of code, make an interactive map and see how your data look. But what's great with the new changes is that right now we have new rendering platform here, GDAL, and with that platform, we can visualize interactively a lot of spatial objects. So here on that animation, you can see example of rendering more than 400,000 lines at the same time in RStudio browser. Also, there is a new package in development called RGE, and this package is for connecting from R to Google Earth Engine. So you can make your calculation on Google Earth Engine without going outside of R. So I think there is a lot of examples, a lot of development still going on with this package. So also, I encourage you to take a look at these changes. And probably very important change for most of us is going to happen tomorrow. So tomorrow is the release of our version 4. So I think we should all look forward to that version because it's going to make changes in our work, and it's also going to make some changes in our spatial work. So that's all for my part, and I'm going to give the screen to Robin to share his knowledge with you.
Okay, thanks a lot, Jakub. So yeah, while Jakub has been talking about individual packages for R spatial and has hopefully persuaded you that there's loads of exciting new developments going on. And I just wanted to add to that a lot of these changes are beneficial for the user. So things are generally getting much faster, and especially the changes with PROJ mean that your geographic research can be more accurate, which is #1 priority if you want to do statistical research that has policy implications. And that's one of my big aims with my research, is to not just make maps because it's fun and because it's creates nice visuals, but also to try and make decisions more evidence-based. So, but in order to do all of this, we need to make sure that we've got the right setup on our system. So assuming everyone can see my screen, yeah, I think that's working. The first thing to say is that a lot of these changes come from upstream, major upstream changes to libraries such as GDAL. And GDAL is a big C library that has thousands and thousands of lines of code, and they have made breaking changes. So inevitably, when people have shifted to support these changes, that's going to lead to some compatibility issues, and it's just important to be prepared for these. So the most fundamental thing to think about is what kind of computer and operating system do you want to have? Do you need to run this stuff? And overall, R is a very efficient way to do geographic research, partly because it does not rely on the graphical user interface of something like QGIS, which is quite memory intensive and CPU intensive. So you can do things on the command line and it is efficient. However, if you want to do large data sets, obviously you need a more powerful computer. R works on all three major types of operating system. That's Linux, Mac, and Windows. And the same applies to R spatial. It's just worth being aware of a few differences between those different setups. So I've done teaching projects for various organizations, including government organizations, where obviously they have quite a controlled computer environment and you cannot just install whichever version of R you need. And there's many organizations who have quite old versions of R. So the first thing to do is, if you look at the description files in these packages, they tell you which versions of R that they depend on. So SF, to provide a good example, depends on R version 3.3.0. But as Jakub said, there's a major release of R tomorrow. So it's good timing to be thinking about when you're going to upgrade your computer to also install the latest versions of packages. I think it's really important to keep your R packages up to date, and that's as simple as running update.packages frequently. And you can also update your packages via tools and update packages in RStudio. And these things may sound basic, and I'm sure they are basic for many of the people listening, but they're really important. So many times when I'm debugging issues or looking at work from students, it's have you installed the latest version of the package type thing. So yeah, basically keep your computer up to date and be ready over the next few days or weeks to transition to this new version of R 4.0, which is a great opportunity. So just a bit about these differences between different operating systems. So it's important to be aware of the upstream dependencies that R spatial is using. And on Linux, which is generally more flexible, you have more control, but with more control comes more responsibility. So you can end up installing versions of the upstream libraries that are not so supported. The good news is that on most Linux distributions, there are good instructions of how to do this. So on Ubuntu, which is a popular Linux operating system that I use, there is a repository and you can just add these lines of code into the terminal, and that will add the latest versions of these upstream spatial dependencies to your computer. And this second line here, sudo apt install lib udunits2, libgdal, GEOS, and libproj, those are the only upstream dependencies that you use. And if you use this first command, you will get up-to-date versions of the upstream dependencies on Ubuntu, which is great because they have some bug fixes and you're using the latest version. On Mac and Windows, it's slightly different. In some ways, it's easier because when you install a package, you get the binary version of the upstream dependency. So on Windows, when you download SF, it actually downloads quite a lot of the binary dependencies. So in some ways, it makes life easier. It can cause problems when, for example, a package updates, and then you can choose whether to compile from source or to use the binary version. And unless you're a relatively experienced user, the advice is generally to use the binary version, which is stable. And for more information, see the SF README. And I'm just going to click on that link to show you what that looks like. So there's quite clear installation instructions for each of those packages. And if you follow those, you should have no problems. So that's about setting it up on your bare metal machine. But if you want to be a bit more experimental, or perhaps you are in an environment where you cannot just install upstream dependencies, or perhaps you want to make sure that your analysis will be reproducible in several months or several years' time, Docker provides a solution for that. So Docker is a virtualization technology, which means that it allows you to run a containerized version of an operating system on your computer. So in a way, it's like a operating system in an operating system. And it's great because it means that you can, not only can you have a stable version of a particular piece of software, so you can ask it to give you a particular version. So I'm just highlighting down here, if you want to get the R version 3.6.3, you can do that. So we have actually created a series of Docker images that are represented in this slide to test out how the R spatial packages that we use in our book, Geocomputation with R, work with different setups. So you can see there is RStudio Preview, so you can test out the a more up-to-date version of RStudio. And in terms of the geographic dependencies, you can run it on the default repos, which is older versions of GDAL, PROJ, and GEOS, so-called OS GeoStack, or you can try the so-called Ubuntu GIS unstable, which simply means that it's the more recent versions of those packages. And that's one way of doing things. But again, that creates a barrier to entry because you need to install Docker, which isn't always easy. So Docker is good if you've got a fairly decent computer that has sufficient resources to have a container inside it. So I would say maybe 8 or even 16 gigabytes of RAM if you want to do number crunching on there. But one amazing thing that I only discovered fairly recently is that there's also something called Binder, which basically provides a Docker instance in a web browser. So I'm going to do a very quick example of this from our Geocomputation with R book. And it's a good opportunity just to flag that there's much more detailed information on how to use geographic packages for a wide range of applications in this book. It's a fully open source book, but it's also available as a physical copy if you would like to have a physical version of it. So this is the GitHub repo associated with Geocomputation with R, and you can look at the development work that we're doing, and we are maintaining this to make sure that it keeps up to date with all of these changes that Jakub has been talking about. So yeah, if I go to this, I can just go onto the github.com Robin Lovelace GeoCompar website, which is a GitHub repository, and I can click on launch binder, and you can see that this screen is appearing. It doesn't launch instantly, and it takes a few moments to set up, but well, actually that one was quite quick. This gives you a completely self-contained version of the software that we are using in geocomputation with R that you can play with and do things with. So for example, I can load the library SF, which is probably the #1 geographic library that I use for my research. And I'm going to make the screen a bit bigger. You can see that that's using PROJ version 7, which is quite a recent version. So this Dockerized version that I can access via a web browser can give you an up-to-date version. And just to provide a small example, I can load another library here, SP data. And one of the simplest things that you can do is kind of hello world is let's make a map. So you can see that we can create a map and do various other things. So NZ buffer, for example, let's imagine that we wanted to create a buffer around New Zealand. We can say NZ and the argument distance that we want to create. Let's create a 10-kilometer buffer around New Zealand and plot NZ buffer. And let's take the geometry. So that's a very brief introduction to how you can use RStudio and R in a web environment, and hopefully you can see there that I've performed a geographic operation on my object and it has worked. So if you want to show off this stuff to someone who maybe doesn't have the computer know-how or the right system, you can just try running geocomputation with R in a binder instance. So that's a really great thing. The next level up, as I say, is Docker. So this is something that I would say it has pros and cons. The cons is that it's fairly advanced and requires computational resources, but the positive is that it allows you to control and use multiple different versions of upstream dependencies. So one example of this that I wanted to show is just here. So I've already got this command up, which is docker run, and then the name of the image that we are going to try and run on my machine is called GeoCompar RStudio DevL. And that means that it's going to try and use the development version of R. And if I run this, that's just in the terminal, you can see that I get some output, and it said that it's starting a service. One of the key things to notice in this command is the P argument, and that tells us which port it's going to be serving the RStudio server instance. So hopefully I can access this containerized version of RStudio if I open a new tab on my browser and I go to localhost, and you can see there localhost 8786, and I put it on that port because 8787 is the default port used by RStudio. And you have a complete version of RStudio, and all of the geospatial packages running on R 4.0. And this is useful for testing out how packages work with new versions of R. If you want to try the bleeding edge stuff, you can try it in a kind of isolated environment and not have to install loads of heavy dependencies on your computer. So that's really great. And we're very happy. I was very happy to see that the book code runs absolutely fine on R 4.0. So I can open the other good thing from a kind of teaching perspective is some of these Docker images in the GeoCompar Docker Hub organization contain a complete copy of the source code of the book. So if I want to take a look at that, I can open the project by going RStudio API, GeoComp, and then there's a R project file there, and that will open up a isolated version of the book, and I can test if all of the code works on this upstream version of the of R. And this will continue. Any further changes, I could use this to test if our book works on the development version of other packages. So does it work with the next version of GDAL? Does it work with the development version of tidyverse packages? So this framework is really good for testing things. And just to test it, and if anyone does want to try to reproduce the book, the way to do it is just to open up this index.rmd file, and then I can set the book building, and that will take some time to finish. So I won't go into the details of that. So going back to the slides, Docker is definitely a useful technology. I think the danger with it is if you don't know what you're doing, you can end up with loads of Docker images. So if you do have a computer that you are free to install stuff on, I would say I would recommend that installing this software and maintaining your own version on your own computer is the #1 priority. And then you can use Docker as a kind of test bed. Docker is advantageous if you want to do big data processing in the cloud. But that's, I think, quite an advanced use case of Docker. So yeah, that's Docker. Another thing that I wanted to touch on, which is also worth being aware of, is tidyverse. I think is an extremely popular framework for doing data analysis. And I think the good news is that over time, our spatial packages have become much more compatible with the tidyverse. So I've just got an example here on the left-hand side that shows if you take the same NZ object that I plotted previously, you can use exactly the same verbs and functions from the dplyr package to manipulate spatial data. I wouldn't recommend using this syntax for spatial operations, but if you just want to do attribute operations, it works really well. So just to be clear, what we're doing here is we're taking the object NZ, we're piping it into the function select, and then it's selecting the population column from that, and then it's slicing it. So it's just taking the first column, the first row from that NZ data set. And you can see there that it gives you a single result. And there's quite an important point there, which is that even though we've told it to select only the population, it gives you the geometry column in addition. So we call that sticky. So the geometry column, which in this case is called geom, is sticky, and it will stick to the object until you explicitly tell R to remove it. And I've got an example of this later on. There's still work in progress. So like any project, it hasn't, like any project worth doing, it's constantly evolving and improving. So this slide just touches on some of the work in progress elements that you may be interested in. So in the tidyverse, there's a lot of time being put into this package called vectors. And I've seen that there's already code in SF to support vectors objects. And there are already also ongoing pull requests to improve compatibility between the SF world and the tidyverse world via vectors. There's also a new approach to dealing with geographic data that basically simplifies the process by forgetting about the complexity of the coordinate reference system, which may be of interest. That's a fairly new, I think it's maybe not on CRAN yet, in development package called GeoVectors. And then a project that I'm involved with called SF Networks is aiming to provide a class system so that you can represent spatial networks that are simultaneously graphs and spatial entities in a high performance, in an intuitive way. So that's some work in progress. There are also some, I think, issues that require further development work. So data table is another framework for high performance computing with R, and there's work to be done in terms of spatial integration between data table and some of these spatial packages. And not all tidyverse functions work at present. So if in doubt, use the base R alternative. So there are workarounds. So I've just got an example here of something that I found useful in my work. The slides contains code that demonstrates 3 different ways of joining together, binding the rows of a spatial data set. And I'm quite interested in performance because some of the data sets that I'm using are national scale, like a national road network can take many hours to process. So you need to think about performance. And just one example, and this is not due to the spatial infrastructure, this is due to base R. You can see that the first option, which is just R bind, is substantially slower, about 3 to 5 times slower than the approach using dplyr. Dplyr, the problem is dplyr bind rows doesn't work on every version of dplyr and SF, so you can work around these problems. So there's a slightly hacky solution where you drop the geometry and then you combine the geometry separately and then put the result back together. That works. And then a great solution from data table, which is the fastest way that I've come across of combining multiple SF objects, is with this function rbind list. But you just need to make sure that you coerce that back into an SF object. So that's a fairly technical slide that touches on how you can use different packages intelligently to ensure get greater performance. So I've done some live demos already with the firing up a Docker image and plotting the New Zealand example. I can continue that during the questions. But one of the key things to note, one of the big advantages of using R for geographic data research, unlike some of the, how I started using geographic data was with a graphical user interface, desktop GIS. The problem with that approach is that it's not reproducible. So rather than me going through line by line, I can just point you towards this demo of a reproducible data analysis of COVID-19, which obviously is a really important issue at the moment. And I think it's amazing to see how you can use other tools in the R ecosystem, like someone's created a package that gives you daily updated COVID-19 data. And then if you know what you're doing with spatial data, you can join on this non-geographic data onto a geographic object, and then you can do attribute joins, which is something that R is really good at. I've done an example of calculating the area, which is obviously a geographic operation, and then build up progressively more complicated maps, and eventually shift to using dots rather than colors to represent the numbers of people, which is deemed best practice by visualization experts. And then finally, in this final code chunk, create a nice animated map to show how official statistics of COVID-19 deaths spread worldwide. So that shows that R is very flexible and powerful. And when you're doing geographic data analysis in R, you have all of the advantages of R's statistical programming pedigree. So you can combine the spatial and the non-spatial aspects. So another important thing about the R spatial community is that it's based on people and communication. So I think one of the best ways to learn and improve your skills is actually to contribute and try to somehow help out the community. So there are many ways to do this. And this is covered in the final chapter of Geocomputation with R. Just communicating your work, telling people your experiences with using R. You can ask questions to colleagues and friends, and people really like to be asked technical questions. So don't be afraid to ask, and certainly offer to help other people who maybe are less experienced. And obviously, there are many places where you can ask for help, and there is no shame in asking. So I've asked many questions on Stack Overflow and GIS Exchange. So just get involved, and if you have any questions, there is certainly a good place to ask, and just use whichever community you find best suits your needs. And that's one of the great things about open source in general. It is diverse, and nobody is forcing you to use any particular framework. And the same applies to the community, is quite diverse. So you can choose which of those various forums is most appropriate for your question. And if you don't know which one to use, just have a look around, see what people are saying, and you will get a feeling for which one is most appropriate for you. And I would say, if you are confident you found a problem, you can also post a reproducible and constructive issue on GitHub repositories. But I would say, make sure that you are confident that you really have found a bug, because if people are just asking general questions that they can find from other sources, that can take quite a lot of time away from important development work that has been going on to make all of this possible. So that's coming towards the end of my slides as well. I've got a plug, which is for a hackathon. It's not on the 16th of May, it's on the 16th of June 2020. And this is going to be an online hackathon to support development of spatial network objects. There is a package that works called SF Networks. And if anyone is interested in joining a completely online hackathon, that should be a really interesting experience. So that's an opportunity for people who are interested in that kind of transport planning and also general R development side to get involved. And that's a great example of how the R community relies on new people coming forward with ideas and trying to get involved in developing. So that brings me nicely on to the final slide, which is next steps. So I've divided it into 3. So if you're just getting started, obviously the first stage is to install R, or even if you have R installed, but it's a slightly older version, tomorrow, the latest version is coming out. I cannot guarantee that it will be smooth sailing. So over the weekend, maybe a really good opportunity to install the latest version and then install some of the key spatial packages like SF and raster. And this is covered in chapter 2 of geocomputation with R, which is just kind of getting started, building strong foundations. And it's worth really trying to understand how these class systems work before diving into complex analysis. If you are interested in the details of recent changes, there's a huge amount of information on the R Spatial blog, and there's good documentation for this new Terra package, which Robert Hymans is designing to replace raster. So you can check that out on his website. There's also another open source book in development called Spatial Data Science, and that has a very good chapter on the stars package. And then finally, there's a very good article on these changes that Jakub presented in his slides. So I've also got some challenges, and one of the things that we wanted to do at the end of every chapter in geocomputation with R is make people think and test people. So the easiest one is just to communicate, find your community, find people who are interested in the same area of spatial analysis as you, and start asking questions and providing feedback. You can test some of these upcoming changes by installing the development version of packages, and it's useful if people provide feedback on how they're working. And you can also contribute to development efforts. So putting in a pull request, even if it's just fixing documentation, can be a really great way to improve your understanding of how R Spatial works. So we've got loads of links and context at the end, but I think that's it for now, and I look forward to looking at all the questions that people have been posting. So thanks everyone for listening.
Thanks, Robin. That was incredible. Thank you, Jakub, also for the joint effort. Maybe let's get this slide over the Q&A session. I always like the one-pagers with all of the URLs. Robin, if you could put this back, that would be amazing. I think this slide is great. Yeah, so we had a brilliant overview of tools. We know that we should be prepared for new version of R, but we were also evangelized about Docker. So there is some rescue. And today we had a lot of people on the chat. There were many questions. Few of them were answered, but still few remains unanswered. And I think it's really good to say a few questions out loud. So those that did not track the live chat also have a chance to get the knowledge from answers. So the first question for you, Robin, are there any upcoming R packages for handling vehicle trajectory data and modeling car following?
Okay, so yeah, that's a great question. And the answer is almost that there's too many. So sometimes you have a problem that a package doesn't exist in R, but because there now are over, I think there's more than 15,000 packages out there, the more common problem is knowing which one to choose. And I think the trajectories one is a great example of this diversity. So I'm just going to open up this paper. So there's a complete paper on this question of which package to use. So I should say I am using our spatial software in my research for transport planning, but I generally work at the city and regional level. So I don't have huge amounts of experience using R for individual traces like GPS traces. However, there is a big community of people using it. I'm not going to I'm going to mention one package that I know of that works well, but I would point the person who asked that question to this paper, which is navigating the R packages for movement. And I actually saw a talk by the person who did this did this analysis, and she said she was really surprised to find how many packages there were. So basically, if you take a look at that paper, that will provide good background. And one that I can personally recommend because I've used it is this traits package, which is by Mike Sumner. So he's an experienced R developer, and I believe this uses SF. So take a look at that paper and check out the traits package. Those would be my two main replies to that question.
Okay, cool. That looks like a wide repository of packages, this paper as well. Another one, I think you're a good suit, Robin. Are there packages being developed to incorporate time geographic theory?
Okay, so it depends what you mean by time geographic theory. So is there any way to get a clarification on what does was it Josh who asked about that? What do you mean exactly by time geographic theory?
Okay, so Josh, if you can, please give more clarification on the live chat, and we will go to the other question for now. Jakub, what about handling satellite net CDF files?
So for NetCDF data, I think we have several options, but right now I would recommend mostly going to the stars package, because stars package has not only a function called read stars, but also the read NetCDF. And there is also another package by Michael Sumner called TiDNC. So you can also use the TiDNC package, but TiDNC is mostly for understanding the data, while the stars is also for manipulating and visualizing the data.
Got it. Thanks. Another one, really fascinating. Are there any plans for more efficient storage or processing of spatial data in R?
Yeah, so I would also say that I think for right now, it's getting better and better. So a few years ago, it was tough to work with larger than RAM data, and right now it's better. In stars package, there is an option in read stars called proxy, and with proxy, you are not forced to read all of the data into your memory, but you only read data when you need it, and you can also make some pipelines before doing that. And also, what's important here, stars proxy allows to dynamically change the resolution of the data, so you can visualize your data very, very quick in some decreased resolution. Also, as we mentioned during the talk, there is a terra package. So terra, the main goal of the terra package is to rewrite the slow parts of the raster package. So most of the user interface is almost identical or very similar, but the performance is is getting better and better. I think there is still some room to improvement, but in terms of processing power, I think there is a lot of action going on. I'm not sure about a lot of things related to storage of data. I would assume that the best idea to store spatial data when you have a lot of data and it's diverse is to use some external database system like PostGIS. And you can easily connect with PostGIS from like a SF package.
Okay, thanks. Nice. Now a tricky question from your fan, Jakub. What is the change in the spatial world that you like and dislike the most?
Yeah, I think my opinion changes all the time because some things that I disliked before I like right now, and some that I enjoy in class. So why I'm saying that, because previously I, like 2 years ago and 3 or so, I disliked that large environment of different packages that are doing the same thing or very similar things. Like right now we can think about like stars versus terra and so on. But right now I'm more and more like that. So I think it's good to have different branches that are developing in parallel universes, and they are creating something new, and they are also forcing other developers to think in different way. And especially when you think about spatial data. With spatial data, we have different problems, different communities, and sometimes it's good to see how different communities work with data and learn from them. So I didn't like that 2 years ago. Right now, I like that diversity. On the other hand, previously, when a few years ago, I really enjoyed the pace of changes, at least some of the changes. Right now, sometimes I'm overwhelmed by this pace, especially as we discussed today. Some changes are very impactful in positive and negative way. They could break your our system or your installation and so on. And because of this, you need to spend a lot of time fixing stuff and making stuff work. But probably one of the best positive parts about ArcSpatial is the community. So I think I'm well known to post a lot of issues on GitHub, to ask people for some improvements or pointing them to some problems. And I love that they are very responsive. I love that they want to discuss and they want to improve. And that's a very powerful. There's a large group of people who are spending a lot of hours every day to make the software and to make the community better. And it's not only about developers, it's also about people like on Twitter who help other people answering questions and pointing them to resources and so on and so on.
Thanks, Jakub. Thanks. Robin, what about you? What's the change that you like and dislike the most in spatial world?
So for me, I think I love making maps. And I think it's fairly established that R has a very rich, powerful ecosystem for making visualizations. And it's, for me, I'm not just making maps because it's fun. I have a purpose, which is to try and influence policy to make it more evidence-based. And I really like the ecosystem for making visualizations. And what's been quite revolutionary for my work is the fact that these interactive mapping packages have come online in the last 4 or 5 years, and there keeps being exciting updates in that area. So one of the great resources that got me into R for spatial data was applied spatial data analysis by Edza Pobesma, Roger Bivand, and others, and Virgilio Gomez as well. And they specifically said a limitation of R is that it doesn't have interactive graphics. When Jakub and I started writing geocomputation with R in 2016, we already had interactive graphics. So that's a really big plus, and it keeps getting better. So you've now got, as Jakub said, MapDeck provides an interface to something called GDAL for really nice high performance web-based maps. And then you've also got the Mapbox map view package that has recent changes enable you to show big data. So that's my favorite thing. Do I also have to, was there a question on what's your least favorite as well?
Mm-hmm.
So it has been the rate of change, but that has affected all languages that are using GDAL and PROJ. And I think what's great about this talk is we've been able to talk not about a specific application, which is what many presentations and researchers want to talk about their specific area, but we're talking about the foundations, and most, if not all, most open source geographic analysis software, whether it's Python, R, or other stuff like QGIS, is relying on these changes, and all of them are having to adapt to these changes. So it's painful, but I get the feeling that the dust is settling at the moment, and it feels like the planets are aligning with R version 4.0 being released, and it seems that things are finally stabilizing. So it has been difficult, and that's one of the challenging things about making an open source book, is that when the software changes, you also have to update your code, but that's been a great learning opportunity as well. So I'm bittersweet about the rate of change, like Jakub.
Mm-hmm. Mm-hmm. Yeah, I can tell. Probably many of the people that are on the audience have felt the pain when developing an article or a small book, and have developed as well over the course of their work, and they needed to update the content and the code. So yeah, I can confirm that's a pain. I've got another question for Jakub, and that's gonna be a mixture of few questions regarding stars and terra. Does terra contain the same functions as stars? When you should use terra, and do you think is there a moment that it's gonna replace raster?
Yeah, so starting from the first part, I think that there is a place for both those packages, because they, first of all, they have, I think, different main features. Because in terms of stars, one of the features of the stars package is that you can work with spatial temporal data. So there is a idea of working not only with space, but also in time, and having many attributes and many bands at the same time. On the other hand, stars, it's not focused that much on some specific calculations, like, so let's say terrain attributes are not, the calculations are not available directly in stars. You cannot have, you don't have moving window calculations in stars, but you have those in raster and in terra. So it depends on what you want to achieve. If you want to work with spatial temporal data, if you want to have maybe NetCDF is better supported with stars right now, but for many purposes like geomorphometric calculations and moving window calculations and so on, I would guess that terra will be as useful, if not more useful, than raster is and was. Regarding the second part of the question, I don't think that terra is can fully replace raster yet, but that's why it's good to visit GitHub of terra to see what the changes, recent changes. And also me and Robin, we try to be active on Twitter, so we often post recent changes in our spatial world. So when we think when something is important or there's a new feature or a new change, we often tweet that. So maybe it's also good to look there for these changes.
Okay, thanks for your answer. So I think it's already been a long webinar. We've got a few more questions, but let me ask last two. And I think there is a way where both of you can make some suggestions and propositions. So one of them is, which sources do you recommend to track changes in the future? And the other one is how to best get prepared for R.0, and what's the safest and best way to update to that version?
So I can answer to the first question better. So you can see right now our last slide. So I think this is a good answer for some of the questions. I think it's one of the ways to be up to date with our spatial development is to go on Twitter and look at the hashtag #RSpatial or hashtag GeoCompare, or look at our profiles, and also look for other spatial developers and advocates for their profiles. And because a lot of discussions, a lot of announcements are happening on Twitter right now. I'm also very active on GitHub, and I also think that starting repositories on GitHub, looking at the GitHub issues, looking at the readmes, also tells a lot of stories and can help you to get up to date with RSpatial. And third group of resources are websites. Some of those we mentioned today, like r-spatial.org, rspatial.org, or our GeoCompare github.io, because we also have regular blog posts and announcements there, so you can see what's happening, what's going on there. We also have some slides from conferences and other talks when we often share the changes that happen in the community.
And I can add to that. So I can add to that reply by saying, if it depends at what level. So I think at the conceptual level, following the conversations that are going on, if you're interested in the code, there's no better place than actually watching GitHub. And it's great to see in real time all of these discussions taking place. So you can look at the pull requests. So if you go on to, for example, the SF package, you can see pull requests coming in and kind of get heads up about changes that are going to come. So do take a look on GitHub as well. And that's a great thing about open source software, is it's got many eyes on it. So the more people looking at code and talking about the code over time, it will improve. So yeah, check out the code on GitHub. The second part, I think, was about how to prepare for R 4.0. So I would say follow the documentation, follow the instructions, follow the instructions, follow the instructions. Like I've had this problem in the past where I just say, oh yeah, I'm just going to update the packages and install it. And then you can end up with, for example, 2 different versions of the same program. Or if you have multiple versions of R on Windows, that can be a big problem. So if you're using Windows, I would recommend removing the previous installation and starting from scratch. And if you are using Linux, just follow the documentation that's appropriate for your particular distribution. And there's a very big Mac community using R. So there are good resources available on there. It's not something to rush, but tomorrow, give it a go when R 4.0 comes out, and you should have a fresh install. And it's a great opportunity to get all of your packages up to date, and maybe something for the weekend.
Got it. That's wise solution. Thank you, Robin. You know, guys, I see two last second questions on live chat. Those are quick. Have you ever considered translating geocomputation to other languages like Spanish?
So I've got a quick fire response from that. So I received a query to translate part of it, which was the history of our spatial, into Spanish from someone called Paulo Palgarin, who's based in Colombia. And I'm not sure what the status of that, but that was just one section. In terms of the book overall, there is I believe, an ongoing effort via a Japanese publisher to translate it into Japanese. I speak a bit of Spanish, so I'd be very interested to see it translated into Spanish, but I haven't heard of any community efforts to do that. But I would be interested in having that conversation, perhaps on the GeoCompar issue tracker. We can continue that. So no, but interested in possibilities for translations.
Yeah. I think the GeoCompar hashtag would be a good way to continue to talk on Twitter. Very wise, very wise. And there's one from Tiernan. Are there plans to integrate spatial statistics packages with the tidy models framework?
Simple answer for me, I don't know. So there's loads of things going on, but not to my knowledge on that one. But if you be the change you want to see, you can ask maybe on, that's a question for the modeler guys, but not that I know of.
Amazing. Yeah, guys, I think that was a great effort. Thank you for the presentation, for the time you invested in making slides. This was a very condensed repository of knowledge. I know that many people will use your slides, so I'm happy that they are published below the video, that there is always a way to find you on Twitter, that there is a book that is published. There are many of resources. And I just wanted to say thank you for tonight, and I hope you also enjoyed the webinar. And just wanted to invite people for the next week, where we will have Lorenzo Braski from Roche IT, and he will present some in-house solutions that they developed at Roche. So you can also build tools on your own in your own company. So Robin, Jakub, thank you once more for your time, and I hope you had a great fun.
Well, thanks for hosting it and making this happen, Martin. So yeah, thank you.
Thanks.